Welcome to Solve Multi-Step Equations. In this lesson, we are going to review how to solve multiple-step equations. This is going to be important as this week we will be solving multi-step inequalities. If we look at these examples here, you notice first of all the one on the right. It's very organized, and it's important to line up the equal sign as you solve equations. If you keep your math organized, your brain will also be organized, and you won't make as many mistakes. The one on the left talks about the different steps that we'll be going through in the next example. Here are 5 key steps to solving multi-step equations. Here's an example that we'll go ahead and run through for each step. So the very first step is to distribute, or in other words, eliminate parentheses. So if I look at this equation up here, I have parentheses. So before I can do anything else, I need to get rid of those parentheses by distributing the 3 into the parentheses. By distributing, I mean multiplying. So I will do 3 times x, which is just 3x. And then I will take 3 and multiply it by a negative 2. Make sure to include the sign. 3 times negative 2 is negative 6. Each time I'm going to write out the complete equation in order to keep it organized. I will also work on keeping my equal sign in the same place. Step 2 now says combine like terms on the same side. Well, if I look here, I don't have like terms on the same side. I have an x term and a constant term. And on this side, I also have an x term and a constant term. So for step 2, I don't need to do anything. I can just keep it all the same. 3x minus 6 equals 5x plus 8. For step 3, we sometimes break this into 2 parts. Move all variables to one side and all constants to the other. Well, our x terms are our variable terms, and our constants, like negative 6 and positive 8, are our constant terms. So let's go ahead and first move the variables to one side. I have a 3x here and a 5x here. In order to move them between sides, I need to add the opposite sign. Well, these are both positive, so I'm going to need to subtract. I can either subtract 3x and move it to the right side, or I can subtract 5x and move it to the left side. Well, in order to avoid having some negatives, I think I will go ahead and subtract the 3x from the left side, which means I will need to subtract it from the right side as well. When I do that, 3x minus 3x gives me 0, and I'm left with a negative 6 on the left side. 5x minus 3x is 2x, and I still have the plus 8. I have now moved all my variables to one side, so I only have x's on one side, not on both sides. Now I need to move all my constants to one side as well. Well, since I put my variables here, I'll go ahead and put the constants on the other side. Since this is a plus 8, if I'm going to add the opposite, I need to subtract 8 from both sides. A negative 6 plus a negative 8 gives me a negative 14. And then I have 2x because 8 minus 8 is 0. That's eliminated. On to step 4. Either divide by the coefficient or multiply by the reciprocal. We really only multiply by the reciprocal when we have a fraction here. The coefficient is the number that is next to the variable. That's called the coefficient. Since I have a number that is not a fraction, I will divide by the coefficient. In other words, I will divide by 2. The purpose for this is to get x, my variable, all by itself. 2 divided by 2 is 1, so that leaves just 1x, which means it's by itself. Negative 14 divided by 2 is negative 7. For the final step, simplify or reduce, well, I've already simplified this and it doesn't need reducing. So my answer is just x equals negative 7. If you'll notice back at the very beginning, on the very first slide, one of the final steps was to check the solution. If you want to know if you're correct, take the negative 7 and plug it back into the original problem and make sure that the left side and the right side are equivalent. That means they equal each other. So we could do 3 times negative 7 minus 2. That's our left side. We could compare that with 5 times negative 7 plus 8. That's our right side. Well, negative 7 minus 2 is negative 9. And negative 7 times 5 is negative 35. Notice I'm keeping track of my order of operations. 3 times negative 9 is negative 27. And negative 35 plus 8 is also negative 27. So my check says I did a good job over here solving, and my answer is truly x equals negative 7. Let's wrap up this video lesson by having you try some examples on your own, and then we'll compare. Go ahead and pause the video and try these 4 sample problems on your own paper, and then come back. First example, we can skip steps 1 and 2. Step 1, distribute to eliminate parentheses, and step 2, combine like terms. But we didn't have any parentheses and we didn't have any like terms. So we would jump to step 3. Move all variables to one side and all constants to the other. I am moving this constant to the other side by adding 5. Notice that I have put an imaginary line here where my parentheses is to ensure that I keep things on the left side and the right side separate. The fourth step says to either divide by the coefficient or multiply by the reciprocal if there was a fraction. Well, we don't have a fraction, so I'm dividing. When I do that, I'm left with x is equal to 14 over 3. The final step says to reduce or simplify. I could simplify this into a mixed number by calling this 3 goes into 14 3 times with 2 thirds left over. Let's look at example 2. Example 2, I also skipped steps 1 and 2. So I'm going to move the constant to the other side, and I get x divided by 4 equals 5. So now in this case, we really have the same thing as 1/4 times x equals 5. So now I'm going to multiply by the reciprocal. The reciprocal of 1/4 is just 4 over 1, or 4. So I'm going to multiply both sides by 4 over 1, or 4. When I do that, 4 times 1 is 4, and 1 times 4 is 4. 4 divided by 4 is just 1. And my answer is going to be 5 times 4, which is 20. And I could leave it as 20 or 20 over 1. Let's move to example 3. 3 is like 1 and 2. I'm going to start by moving my variables to one side and my constants to the other side. When I move over my 5x to the left side, I'm going to add 5x because this is a negative 5x or a minus 5x. So then I get negative 7 plus 16x equals 9. These cancel. Now it's time to move over my constant terms. So I'm going to add 7 to both sides. These then cancel, and I'm just left with 16x is equal to 16. My final step then is to divide by the coefficient or multiply by the reciprocal. I'm dividing by the coefficient. X equals 16 over 16, which if I reduce that, gives me 1. For the final example here, I will actually need to do step 1. I have parentheses, so I will need to distribute. 5 times x is 5x, and 5 times a negative 1 is negative 5. Now I can move on. Step 2, if you remember, says combine like terms on the same side. However, we don't have like terms on the same side, so I can move on to step 3 like the other problems. I'm going to move my constants to the same side and my variables to the other side. I am now then left with just 5x on this side as my 5's cancel. 7 plus 5 is 12. And then my final step, I'm going to divide by the coefficient, and I'm left with x equals 12 over 5, which I can leave like that, or I can simplify. 5 goes into 12 2 times with 2/5 left over. 2 final examples before we close out today. Again, pause your video and see if you can do these two on your own. When you come back, the answers will be provided. Example 5 is a little trickier because we have a fraction. But remember, we're still multiplying, we're still distributing it. So we have 3/5 times 5x, which is the same as 5x over 1. Now we can just multiply across. 3 times 5 is 15x. 5 times 1 is just 5. Over here, remember the minus sign, we have 3 times 10, or 10 over 1. 3 times 10 is 30, and 5 times 1 is just 5. Let's simplify this a little bit. What's 15 divided by 5? Well, that's just 3x. And what's 30 divided by 5? That's just 6. Notice that the minus sign here and here comes from here, and it's still there. Now I can move on just like the other problems and move my constants to one side. So I would add 6, and I would be left with 3x, these cancel, equal 5. Divide by the coefficient in this case, and I have x equals 5/3, which is the same thing as 1 and 2/3. Let's look at the final problem. 3 consecutive numbers add up to 66. Well, what does consecutive mean? Consecutive means it follows one after the other. So if I start with 3, then 4 and 5 would be the next consecutive numbers. If I started with 100, then 101, 102 would be the next two consecutive numbers. So in order to solve a problem like this, we need to use symbols to help us. What we would do is say that x would represent the first number, whatever it is. So what would be the second number? Well, that would be x plus 1. And what about the third number? That would then be x plus 2. We know that they all add up to 66. So now I can write this as an equation. If I take the first number plus the second number plus the third number, they should all add up to 66. Using my rules for solving a multi-step problem, this would then be in step 2, which says to combine like terms on the same side. Well, I have 1x here, 1x, and 1x. That's a total of 3 x's. 1 and 2 is a total of 3. Now this looks just like some of these other problems. I can move the 3 over, that's my constant term, and I would be left with 3x on this side is equal to 63. Finally, for my last step, all I need to do is divide by the coefficient, which is 3. These cancel, and x is equal to 21. And that concludes our lesson today on solving multi-step problems. Remember that when you solve these problems, it's good to check your solution by plugging it back into the original problem. It's also a good habit to keep your equal signs lined up in order to keep your work organized.